Hey there everyone. Today we'll be continuing our topic of binomial theorem. Last time we did a question which required us to compare coefficients to find the values of, in this question, a, b and c. Today we'll be doing another question like this, alright? This time it is once again saying to us that the binomial expansion of 1 plus 2x power 4 minus 1 minus 2x power 4 is comparable to ax plus bx squared, and now they want us to find the value of a and b. So then, how are we supposed to do this? This time, we will not expand these terms one fully. We have to do is find the x power 1 and x power 3 from this. Alright, so then, how are we going to do such a thing? See, as you can see that the a normal power of n is there, it is not negative. Thus the power of x will only increase in an ascending order, and because x initially both the x's has a power of 1, thus they will increase in an ascending order of 1, 2, 3. Alright, so then let us just do this. As we can just see that this is b. Alright, this is b, 2x, and b has a power of r. So if I say NCR and r is 1, so then b, which is 2x, will have a power of 1, therefore the x will have a power of 1. So what we can do is 4c1, 4 is n and r is 1, a is 1, 4 minus 1, which is 3, and b is 2x power 1 plus, now the next term we need is in cube, so we can say 4c3 into 1. 4 minus 3 is 1. B is 2x power 3. This gives us 4 into 1 into 2x plus 4c3 is 4 into 1 into 2 power 3 is 8x cube. Alright, now then this gives us 8x plus 8 into 4 is 32, therefore 32x cube. Alright, now then if we notice something, it is that these two are exactly the same. Let's see here, let me show you that these two, this and this, are exactly the same. The only difference is the negative sign. Alright, so then all I have to do is replace this x with minus x. As you can see, the only difference here is that there is plus and this is minus, so all I need to do is replace the value of x with negative x. Plus 32 into minus x cube, so then this gives me minus 8x minus 32x cube. Alright, so then the next thing that we need to do is subtract both of these. So I can write 8x plus 32x cube minus 8x minus 32x cube, which is now comparable to ax plus bx cube. And now to resolve this, 8x plus 32x cube plus 8x plus 32x cube. 8x 8x gives us 16x plus 32 and 32 gives us 64. So 64x cube comparable to ax plus bx cube. Alright, so then the coefficient of x here is a and the coefficient of x here is 16. Therefore a is equals to 16. And here the coefficient of x cube is b, and here the coefficient of x cube is 64. Therefore the coefficient of x cube is 60. Therefore b is 64. Alright, pretty simple. Alright, then here we have another comparison question. However, this time we have not been given the value of n and the value of a. They have asked us to find the value of a and n. So then what we need to do is write 1 plus ax n, and this gives us 1 power n plus nc1 into 1. This becomes n minus 1. and this is ax, b is ax, it is a power of 1 plus nc2 into 1 n minus 2 into ax squared, right? Because ax is b and b is the power of r is 2. Alright, now then, remember that any power on 1 does not affect 1, alright? So 1 will be 1. Now then, as you know that anything with c1 gives the actual value. So nc1 is n into 1 into ax plus nc2. Now then, how are we supposed to solve nc2? If you remember, at the start of our lecture, I told you a few things on how to expand NCR, right? I told you that if we have 4C2, you do 4 into 3 over 2 into 1. You basically count backwards the amount of times R has told you. R has said 2. So we counted backwards 2 times, 4 into 3 over 2 factorial, the actual r factorial, right? And same for here, like in 5c3 it told us to count backwards 3 times, so that is what we did. We said 5 into 4 into 3 3 times. Well, now 5 is 1, 4 is 2, 3 is 3, all right, and then we did over 3 factorial. Now then, as you can we need to notice another thing, that they were being minus 1 then 2 then 3, right? Because 4 is 5 minus 1, 3 is 5 minus 2. So this time our n is 5 is our n. So what I can say is n minus 1, n minus 2, right? Pretty simple, right? N is being minus from the same here, right? If you can see here that n into n minus 1 into n minus 2, it keeps going on until r. So let us go here now. This time it is saying nc2. It wants us to minus n 2 times. It wants us to count backwards 2 times. So what I can say is n into n minus 1, right? N is the first value and n minus 1 is the second value. And over 2 factorial. See, pretty simple. Into 1, a square and x square, right? Because both of them were whole square, so both of them will receive a squared value. So this 1 plus nax plus, all right, so this becomes n square minus n over 2 into a square x square. All right, this is our term. Now then, what we need to do is replace this term with this so we can compare the coefficients. All right, so I will write 1 plus nax plus a square into n square minus n over 2 x square, right? I just did this to make it easier for me to recognize which is the coefficient of which, is equals to 1 minus 12x plus 63 x square. All right, now then it is time to compare coefficients. 1 is 1, so we don't need to compare that. Now we compare the coefficient of x this time. So then here the coefficient of x is n a and the coefficient of x there is minus 12. Now then, we can make one term independent here. So I can just say n is equals to minus 12 over a. Alright. Now then, I can compare the x values. I can say a square into n square minus n over 2 is equals to 63. Okay. What we can do is replace the n values here, right? But it would be a bit difficult because we'll have to replace two values. So what I can instead do is do this. Make a independent and n in the denominator, alright? So I can just replace this a and write 12 over n whole squared into n square minus n over 2 is equals to 63. I can move this 2 there and this can be multiplied with these, alright? So this becomes, oh sorry, but first we need to open the square. So this becomes 144 over n square into n square minus n, and this 2 goes over to that side, so this becomes 63 into 2. Now then, I can multiply these. This becomes 144 n square over n square, and this becomes negative 144 n over n square, and this becomes 63 into 2 is 126. Now then, I can just cut these, so this becomes 144 n square. Or rather than cutting them off, let us do something else. Let's just say this is 144n square minus 144n over n square equals to 126. Alright, now then I can just move this n square there, so this becomes 144n square minus 144n. This becomes 126n square, right? Now then I can move this n square to that side. So this becomes 144n square minus 126n square minus 144n equals to 0. So this becomes 144n square minus 126. This becomes 18n square minus 144n equals to 0. Now then, what I can do now is take n common from this. So this becomes, what I can do here is take 18 common from this and n from common from this. So then this becomes 18n, alright? So this becomes n minus 8 is equals to 0, alright? Now then, at 18n is equals to 0, therefore n is 0. And n minus 8 equals to 0, therefore n is equals to 8. Now then, I have the value of n, alright? Now to pick the value of a, alright? N could not be 0, right? Because if it was 0, we would not be able to expand this term. Therefore, we will deny n equals to 0. We will pick n equals to 8. If we did the power of n as 0, this whole term would become 1. So this would not become comparable, alright? Now then, I have a equals to minus 12 over n as we found out above. So I can say minus 12 over 8. So this becomes 12 over 8 is 3 over 2. This becomes negative 3 over 2. Thus the value of a is negative 3 over 2 and the value of n is 8. Alright, now then we have here another question regarding the binomial expansion. This time it is asking us to expand the binomial expansion of this term 2 plus under root 3 whole power 5 in the form a plus b under root 3. So then what is this form? This is what you can call an exact form. An exact form is a form which is not in the decimal. Basically, to say it in an easy words, you basically get the answer from your calculator and directly put it in. If it is in fraction, you do it in fraction. If it is in under root or something else, you just do it like that. You do not convert that thing into a decimal form. Alright, so it is asking us to like expand this and then give the answer in the form a plus b under root 3. So then let us do that. Part I. It's so that 2 plus under root 3 power 5 is equals to 2 power 5, right? Because 2 is a and under root 3 is b, plus 5c1 into 2 power 5 minus 1 is 4. And then b is under root 3, so the power is 1, plus 5c2 into 2 power 3, because 5 minus 2 is 3, under root 3 squared, plus 5c3 into 2, 5 minus 3 is squared, plus into under root 3 power 3, plus 5c4 into 2, 5 minus 4 is 1, under root 3 is 4 power 4. Alright, and now plus 5c5 into 2 power 5 minus 5 is 0 into under root 3 is 5. Alright, now then to resolve this, 2 power 5 gives us 32 plus 5c1 is 5 into 2 power 4 gives us 16, and under root 3 is under root 3 because it has a power of 1, plus 5c2. What does 5c2 gives us? It gives us 10 into 2 power 3 is 8, and this gives us under root 3 squared is 3, plus 5c3. This once again gives us 10, 2 squared is 4, and now under root 3 is cubed. So then this gives us 3 under root 3, alright, plus 5c4. What is 5c4? 5c4 is 5 into 2. And now under root 3 has a power of 4. So this gives us 9. Plus 5c5 is 1. 2 power 0 is 1. And now under root 3 has a power of 5. So this gives us a weird answer, So what do we do? Alright, if you plug it into the calculator, this thing, let me do it better for you. So if we plug in this, it will give us an answer something like 15.588. So then, how am I supposed to avoid the situation? Because it wants an answer in exact form, not in decimal form, alright? So how am I supposed to, resolve this? Let us see. So if we notice something, under root 3 is has a power of 5. Alright, it has a power of 5. So if can I not write it like this, under root 3 squared into under root 3 squared into under root 3, right? Because if I do this, won't these powers get added like 2 plus 2 plus 1, right? Because they are being multiplied and the whole power gets added. So if I do it like this, what I can just do now is under root 3 becomes 3, under root 3 becomes 3, and this remains as under root 3. Therefore, this becomes 9 under root 3, right? If you do it in your calculator, 9 under root 3, you should get 15.588, which you got last time. So this is how you resolve these types of terms, right? So if you got like under root power 6, you would have done under root 3 squared into under root 3 squared into under root 3 squared. So this would have become 3 into 3 into 3, which is basically 3 power 3. So this is 27, right? Pretty easy, right? So this is how you would have resolved that. So here I can write 9 under root 3. All right. So I'm going to remove this because you probably know what this is. So this becomes 32 plus 5 into 16. This gives us 80 under root 3 plus 10 into 8 into 3. So this gives me 240 plus 10 into 4 is 40. 40 into 3 is 120. So this gives us 120 under root 3. And now 5 into 2 into 9 is 90 plus 9 under root 3. Now then, to add these terms, the normal terms will get, the integer ones will get added with other integers. So 32 plus 240 plus 90. This gives me 362, right? I added these terms, 32 to 40, 90 to get 362. And now I am going to add 80 under root 3 plus 120 under root 3 plus 9 under root 3. So this would give me 329 under root 3 plus 329 under root 3. Oh, my bad. I made a small mistake. This should be 209. I made a mistake when adding these terms. So this should be 209. All right. So by adding these three terms, I got this. All right. Now as the question asked, we have done so. A is 362, B is 209, and B had an under root 3 with it. Therefore, we have given the answer in exact form. Now then, part 2. It is asking us to state the result for the expansion of 2 minus under root 3 power 5. So nothing has changed, only this positive has turned from only this has turned this sign is turned from positive to negative. So all I have to do for part 2 is write 2 minus under root 3 power 5, and now just make a small change, which should be if you were to notice, we did negative x whenever we had negative. So, but this time we have no x for it. So we will just change this positive sign to negative. So 362 negative 209 under root 3. Okay, it wants us to expand the term. So all I had to do this time was just replace this negative. Or if you are confused by yourself, you can just do the whole thing and replace this under root positive under root 3 with negative under root 3. You will end up with this. All right, but it is a shortcut that if these are the same terms, all you had to do was change the negative sign. Or to make it even better, if you had, like, for example, more terms, like let's say you had let's call it A, B, and C. Now then, how are you supposed to decide where to, replace positive and negative? So whenever you have a negative sign, our series goes as negative, then positive, then negative, then positive, then negative, then positive. This is how a negative binomial series goes, all right? So all you would have had to do was replace this with negative and that, and these two with negative, because of negative, positive way of series. All right, but this time we only had one, so we do not need to worry about A, B, and C. This was just an example for future if you ever encounter any question like that. Okay, however, we are not done with part 2 yet. It is telling us, or wanting us to show, that 2 minus under root 3 power 5 is the reciprocal of 2 plus under root 3 power 5. Now then, what we first need to understand is what a reciprocal is. So, if I have a term called a, and now if I were to reciprocal it, what I would do is take this a into the denominator. So this would become 1 over a. This is what we call a reciprocal, right? So like whenever we are doing these types of things like 5 over 4, and now we are like, how should I resolve this? So normally our teachers ask us to do 2 over 3 divided by 5 over 4. Now they tell us to take the reciprocal, which is basically shift these two. So we do 4 over 5. So this, now we are able to resolve this, which becomes 4 2s are 8, 5 3s are 15. This is how we normally resolve these types of divisions. But what here we are doing is what we are reciprocal. We are doing reciprocal of an equation, right? So if I have 2 over 3, the reciprocal of this would be 3 over 2. Right? We are not changing any power signs. Reciprocal does not change power signs. So what we can realize is that if we multiply two reciprocals, right? If I multiply a with 1 over a, this would basically cut these two a's, right? It would cut these two a's and give me an answer of 1. So this makes us realize that reciprocal of any two terms will always give us 1. So if I multiply two reciprocals, for example, let's say this 2 over 3 into 3 over 2. If I multiply the reciprocal of each other, they will cut each other out and give me 1. So now they are telling us to show that these two are reciprocals of each other. So what we can do is basically multiply these two, and if these two give us an answer of 1, that means that these two are reciprocals of each other. So I have the first one as 362 plus 209 under root 3 into 362 negative 209 under root 3, right? And this should give us an answer of 1. So what I can do is start multiplying these terms. 362 into 362. This would give me 131,044. And now when I multiply 362 with this would give me 362 into 209. This will give me negative 75658 under root 3. And now to multiply 209 with 362, then this would give me 209 into 362. This would give me positive 75658 under root 3. And now multiplying this with this term, it would give me negative 209 into 209 and into 3. This would give me 131043, and this should be equals to 1. Right, now then, if I resolve this 131,044 negative 131,043, this would give me 1, and these two would cancel each other out. Therefore, 1 is equals to 1, and now we have proven that these two are reciprocals of each other. Alright then, here we have the last question for today. In this, it is asking us to find the expansion of 1 plus x square power 4 in ascending powers of x as far as the term in x cube. Basically, it wants us to expand this until x cube. Now then, this time we have three terms, 1, 2, and 3. How are we supposed to expand a binomial of three terms? So, in such a situation, we have to consider 1 as 2 as 1. So, here I'll say 1 is a, and x plus x square as a whole is v. Alright, so I'm considering x plus x square as a single term, which is b. Alright, now then, till how much should we be expanding such a equation? As you know, b will have a power of r, and like when it goes to, like, for example, let's say x plus x square, it will obviously become a tedious task to expand this, and also, sorry, cube, it will become a tedious task to expand this, and also we can see that, you know, it is a cube, right? So x will become a cube there, so we do not need to expand this fully as well. All right, now then, let us see how much further we should be going. Let's say 1 plus x square power 4 is equals to 1 power 4 plus 4c 1 into 1, which is 4 minus 1 is 3, into b is x plus x square power 1. And now for 4c2, let me just move this over here. 4c2 into 1, 4 minus 2 is 2, x plus x square is 2, x plus x square is, yes, it is 2, and then 4c3, 1, 4 minus 3 is 1, and x plus x square is 3. All right, now we do not need to move we do not need to move till 4c4, as the power of r will become 4, and like when this is like 4, none of the x terms will have a cube in it, so we don't need to do that. All right, now then, this becomes 1 plus 4 into 1 into x plus x square plus 4c2 is, if you do it, it will give us 4c2 is 6 into 1 into, alright, now then, if we expand this, this will give me x square plus 2 into x square plus x square squared, right? So see, if I x square square, I will get x power 4. Therefore, I do not need to write this, so I can just eliminate this from here to save our time and space. Alright, I can just put in dots in its place. Now then, 4c3 will give us 4 into 1. Alright, now if I expand this, this will at the start will say x power cube plus this would give me 3, you know, like it gives us, if you know this, it gives us like 3a square b, right? So if I say 3 into x, and I say square into b is x square. So if you see, when you multiply these two, it will once again give me x power 4, so which will once again become a useless task for us to do, right? So I do not need to continue this whole expansion. I can just write dot dot again in its place. It is useless to continue that expansion, so this will give me 1 plus 4x plus 4x square plus 6x square, and then 6 to the 12x cube. All right, and for this it will be 4x cube. Okay, pretty simple up till now, right? 4x plus 4x square plus 6x square plus 12x cube plus 4x cube. And now all we need to do is add these terms, 1 plus 4x, and then this becomes 10x squared, and then this becomes 16x cubed. And this is our binomial expansion of a 3-term binomial, alright? That's it. We'll do the rest of the questions in the next class.